Hello, everyone, and welcome to the Unstoppable Duos webinar featuring Fortress Power and Sol-Ark. Our presenters today are John Cromer, Fortress Power Applications Engineer, and Dylan Hillman, Engineering Support Director from Sol-Ark. Make sure to please submit all of your questions in the questions tab throughout the presentation. Also note, everyone who registered will receive a recording and slides from the presentation tomorrow afternoon. So without any further ado, John, please take it away.
All right, welcome everyone. We're going to say a few things about the Fortress Power product line, then pass over the presentation to Sol-Ark, and then we'll circle back and talk about popular design configurations. Feel free to ask questions during the program so you don't forget what they are. If your question is not asked during the program, answered during the program, you'll get a follow-up from either Fortress or Sol-Ark to that. But we'll try to get to you. If too many people ask questions, we'll just answer them at the end of the program. So just a little bit of quick information about Fortress Power. We are a lithium iron phosphate battery manufacturer. Our headquarters are just outside of Philadelphia in Southampton, Pennsylvania. You can see our test lab. We have a solar array on the roof. And we also have shipping and logistics centers on both coasts. We're also a global manufacturer. We have installations all over the world. The United States is our primary market. We're also very heavily focused on Latin America markets as well. Some things that separate us, and also, one reason why we like Sol-Ark as well, they share very similar philosophies on having a hands-on management team with personalized service and support. It's a company with a reputation where you call their tech support line, you're going to get someone following up on your case shortly. For installers who are part of our installer loyalty program, we do co-marketing with some marketing budget and lead generation. We provide a lot of design and installation support. So we're not going to design your project for you, but as you have questions from preliminary design all the way through installation and commissioning, we're a company that you can get answers from. Both Sol-Ark and Fortress are NABCEP registered continuing education providers. So we have various webinar trainings if you need NABCEP credit. We have 3 classes registered with NABCEP for recertification credit, and installers who join our Discord community can take those classes on demand and get those credits out of the way. Finally, both Fortress and Sol-Ark, we have spare parts and servicing out of our headquarters, and so while it is unfortunate when issues arrive where you do need to make some type of repair on a product, you can actually get that done. My background is from the solar installation community. I know there are a variety of inverter and battery manufacturers out there that do not run any spare parts in their inventory, and so if whether it's a manufacturer error or a field installation error, being able to get those issues serviced is invaluable. And so that's some of our broad appeal from the installation community. We distribute through your standard online solar distributors. If you have questions on where to buy our products from, you can visit our website /where-to-buy, and that'll get you in touch with our sales managers for different regions to help you out with that. Finally, our products do qualify for financing with your major solar financing companies, and so in many cases this can result in cash positive project financials throughout the ownership cycle of the project. Let's talk about our product line quickly. We have 2 main products that we're going to highlight in today's presentation: the Fortress eVault, which is an 18.5 kilowatt hour battery, and the Fortress eFlex, which is a smaller battery at 5.4 kilowatt hours. The eVault is the cost-effective, popular solution for easy, large installations. You can have 12 of them in what we call open loop. More on that later. You can stack 12 of them up to each other. That's up to a 222 kilowatt hour battery bank. We can do closed loop again, more on that later. With Sol-Ark, up to 2 eVaults or 37 kilowatt hours. So for projects where you're looking for the most cost-effective installation to get the most kilowatt hours stored for your buck, the eVault is our flagship product for that. It's easy to install. Many projects will only need one Sol-Ark inverter and one eVault, and it's as simple as taking the battery cables off of the eVault and landing them onto the battery terminals on the Sol-Ark, and that is the extent of your physical installation of the battery. Because it is so large, you often can just meet most of the home's needs for backup purposes or for things like time of use metering with just one eVault. It is the largest standalone battery on the California SGIP incentive program list. We like the concept of a battery manufacturer making the batteries, the inverter manufacturers making the inverters, and then having the products be agnostic on working with multiple different products. However, what we find is by working with every product, there are certain products that rise to the top, and so we see a lot of our installations going with Sol-Ark, hence the reason for the webinar today. The eFlex battery per kilowatt hour stored, so per unit of storage capacity, a little bit pricier than the eVault, but to some extent that increase in cost comes with some features that you might find useful on a particular job site. So for instance, just the fact that it is 1/3 the size of the eVault means that it is easier to transport. You can unhook it from the battery rack and take it home with you if it ever would need charging or servicing and you don't have what you need on site. If the site is in a basement or up and down stairs, dealing with the right equipment to get these heavier eVaults up and down the stairs may not be worth it on a particular site. We also have a variety of mounting options. You can mount we have a wall mount kit that allow you to mount it on the wall. You can floor mount the eFlexes. You can also fit them into a server rack. And the eFlex will do closed loop communication up to 81 kilowatt hours. And so if you want to do a commercial project or a large battery project and have that closed loop communication, again, more on that later, the eFlex may be the better choice. Finally, I want to talk about the rugged aluminum case of the eVault. It's an IP65 case. What that means is that it's waterproof. Actually, there are different kinds of waterproof. What this IP65 case is it's a sealed case that is waterproof against rain contact and also humidity from getting inside the case. So you still need to protect the battery terminals outside the case. That makes it more appropriate for damp environments rather than wet environments. But in terms of your day-to-day rainwater and your day-to-day humidity getting inside the battery is protected from that. And so when you look at what causes a battery to degrade, you have thermal, heat issues, rain and humidity issues, and dust. You're not going to get the rain and humidity and dust into the eFlex case. That makes it particularly well suited for outdoor installations. And of course, Sol-Ark has an outdoor unit for their inverter. We try and make everything about our products great. Even the aluminum case itself is ridged to give it some heat sinking capability that does transfer thermal heat outside the battery more quickly than our competitors' products. It also has a channel for T-slots built in the back, the same T-bolts you use on your solar job sites you can fit into the back of the case of the eFlex so that you can build custom mounting solutions with ease. This is a Sol-Ark Plus Fortress webinar. And so one of the hot topics is closed loop communication. So closed loop communication is where the onboard computer inside our batteries is communicating not just battery to battery, but also carrying that communication stream all the way into the inverter and communicating the information from the onboard battery computer onto the onboard Sol-Ark computer. So why is that necessary? Well, many inverters have state of charge controllers on their inverter systems, but that historically is because batteries have not had onboard computers in the battery system. So while we're all trying to do things like calculate how full the battery is, it can result in communication error. Even if we're speaking the same language, there's an, an extent of accuracy between what the inverter will think the battery state of charge is at and what the battery is actually at. So these lithium ion high-tech batteries are taking over the controls in terms of telling the inverter what the percentage state of charge is. Just one note on percentage state of charge, it's actually pretty hard to calculate. So here we have from 0% full to 100% full, we're looking at the battery voltage. And whereas lead acid voltage levels are more of a straight line, what we see with rapidly dischargeable and chargeable batteries such as lithium ion, the voltage drop curve is much more of a plateau with a big cliff at the end. And so determining the state of charge, particularly in the middle range of the battery, where the resting voltage of the battery does not change that much, knowing what the percent state of charge is a rather difficult calculation. And that's why it's really up to the onboard computer of the battery itself to come up and translate that voltage level into a percentage level rather than having some third-party onboard calculator do it. And so to improve the accuracy of your state of charge information to the client, that closed loop communication is important. There are other reasons to have closed loop communication, and we're going to get into those reasons a little bit later on in the presentation. But what are the benefits that closed loop provides? The first is it's the difference between relaying the battery voltage and the battery state of charge. So the battery voltage, when it's relayed from the battery to the inverter, you don't need a fancy computer for that. And that is because the battery itself, the positive negative terminals are landing on the inverter, and the inverter can sense what those positive and negative voltages are and come up with its, have a very accurate understanding of what the battery voltage is. But because of the flatness of the voltage curve, translating that voltage into percentage state of charge is very difficult. Of course, customers, they don't want to know what the battery voltage is at. They want to know what the battery percentage is at. And so in order to accurately convey the battery percentage to the customer, you have to have closed loop communication. So it's very much understanding how percent full the battery is a customer want. And so to provide you focus on what the customer actually wants to pay for, selecting closed loop communication is vital in customer satisfaction. So for that extent, the manufacturers on our side of the fence, we really look at closed loop communication in terms of controls and having the battery computer talk to the inverter and control the system. The customer doesn't really have a comprehension for the behind the scenes controls. What the customer really wants the closed loop communication for is monitoring, being able to look up in their online monitoring system and see exactly what percent state of charge the battery is at. And the only way to do that accurately is to have closed loop communication. Another advantage of closed loop communication is that you can reduce the minimum battery size of the battery itself. And this is because you get boosted charge and discharge rates. In that middle range of the battery, it's okay to charge the battery a little bit faster as long as you can slow it down at the end. And so what closed loop communication does is it allows us to charge at a little bit higher of a charging voltage, a little bit faster of a charging voltage. If you read our warranties and our spec sheets closely, we have recommended charging and discharge amperages, a warranted range that is slightly above the recommended charge and discharge amperages, and then the maximum charge and discharge amperages, which are intended to be used infrequently rather than regularly. When you enable closed loop control, our battery management system talks to the inverter and it says, okay, we can charge at a little bit higher voltage, we can charge at a little bit higher amperage without running into the issues of what happens at the top or bottom range of the battery. So we have more braking mechanisms in the charge that allows us to accelerate our battery a little bit more quickly and ride the brakes a little more strongly to get that battery to charge and discharge even more quickly. So there are some performance advantages of going with closed loop communication, but the number one advantage that the customer is focused on is being able to see that percent state of charge and have it be an accurate representation of what is inside the battery. Now we do have a few resources that I want to emphasize. We'll circle back to them after the Sol-Ark portion of the presentation. But on our website, we have a chat widget powered off Podium that customers use regularly to ask questions. If you are an installer, we have better resources for you to take advantage of. You can always email tech support at fortresspower.com to get a response on your questions. You can give us a call to talk with us if you would like to. And then last but not least, we run a technical support forum and a chat program called Discord. Here's our Discord invite link. If you email tech support at fortresspower.com, it's in the technical support department. It's in our email signatures. You can click and join. And sometimes this Discord group is a little bit easier when you're doing preliminary design to ask, if you're the type of person who likes to ask a lot of questions, the Discord group will categorize those questions a little bit easier for you to retain all the information. Also, if you are installing in the field on sites where internet signal is intermittent or cell phone coverage is even worse, sometimes doing it in a web app rather than relying on the actual cellular antenna can get that data over to us so that we can support you in real time between the field and the office. With that, we're going to introduce Dylan. He'll talk a little bit about the Sol-Ark platform. Feel free to continue to ask questions. Then he'll pass it back to us and we'll finish out some layout discussions and programming instructions, and then go over to a dedicated Q&A section at the end. So with that, Dylan, I'm going to pass it over to you.
All right, thanks, John. Hi, everyone. I'm going to be going over some stuff about the Sol-Ark today, some of our customer support, lead generation kind of stuff that we do, our new outdoor Sol-Ark 12K and some of the benefits to that, how it's simpler to install. We did a lot of software improvements, especially recently. I'm going to go through quite a few of those as well. And then lastly, we came out with a lot of really cool ESS design tools that are on our website. So with that, I'll jump right into our first slide here. So first off, we're very proud of our customer satisfaction. You can see here that we were voted #1 in that category. And as a result of that, we have a ton of installers available on our map. You can see here in orange and distributors in blue. And a lot of you guys are probably installers on the call today as well. So I'd love to let you guys know, we do a ton of training. You can actually become an installer for us on this map as well on our website. I think we trained over 2,000 people last month, so we're always doing trainings. You can get on this map right here, and we actually do lead generation as well. We do 500 plus leads frequently in order to do that per month to do that. And if you want to get on that map, that's awesome. And then of course we do offer 7 days a week engineering support. So even if you need us on the weekends, you'll always be able to get a person to help you out with what's going on. So here's kind of a skeleton view of the internals of a Sol-Ark 12K. We have 2 built-in MPPTs, which gives you some flexibility on how many panels and what kind of string lengths you're going to be able to do for the Sol-Ark. We have cloud monitoring that comes built in. It's actually a removable dongle, but it comes with the Sol-Ark at no additional cost. And I'll jump into more details on how the monitoring platform works here in a little bit. There's a lot of smarts built into the inverter. I like to say that we're basically the Swiss Army knife of inverters out there. So there's a ton of different modes that you can use to get the inverter to do whatever it is you need it to do. And we have a whole separate document that you can actually request from our support team that goes over, it's like a 10 or 15 page document on just modes, on different ways to set up the inverter. You can do straight up grid cell, you can go fully off grid, you can do time of use, peak shaving, everything in between, a ton of those modes all at once as well. So we can get into that a little bit more later if you like. Then there's also a ton of sensors built into the system, of course. We've got all the usual suspects like temperature sensors and all that kind of good stuff. But as Fortress has been mentioning, we also do communications, closed loop communications with batteries. We do automatic generator start. We have a couple different rapid shutdown and emergency stop options as well, all built in and ready to go. Next up, we have, actually, if I could go back to that slide there. So we are battery agnostic, but obviously we are a big fan of Fortress, so that's why we're here today. And then on the AC side, of course, we've got our grid connection, load connection, and then we have kind of our Swiss Army knife breaker as well. And that can either be a smart load, which is a kind of an automatic load shedding kind of thing. It'll only power those loads if you've met some criteria that you can program in the Sol-Ark. You can plug in a generator to that port, or you can even AC couple to that port. And then lastly, over here on the right, we do include a 250 amp battery breaker in the Sol-Ark, which is really handy for install. And then you can see the breaker sizes there for some AC pass-throughs.
Yeah, and Dylan, not to rain on your presentation, but just some things on this slide that I particularly love about the Sol-Ark inverter. That well-sized 63 amp grid pass-through is a little bit larger than the competition, and that really allows you to supply a lot of grid-tied power onto those critical load panels, so you can put a little bit more juice on the critical loads. That's really nice. And then finally, in terms of what's a good solar size to combine with a Sol-Ark unit, doing the DC coupling, you can get up to 13 kW on solar. And so when you're doing a Sol-Ark, you're like, well, how much solar should I do? Going all the way up to 13 kW per Sol-Ark unit is quite cost effective. And when you look at the price of not having an all-in-one unit, but separating it out, buying the inverter separate from the charge controllers, separate from the auto gen start, separate from the switch gear put into the bottom of the Sol-Ark, it is so much more expensive than having the all-in-one unit. And of course, Sol-Ark knows that, because that's why it is so popular today.
Yeah, no, those are great points. And actually, you see someone in the chat asking as well, but we can AC and DC couple at the same time. There's going to be some limitations on like how much total you can do because of the breaker sizing, but you can absolutely do that. You could have a 13 kW DC coupled array and throw in like another 3 kW at least of AC coupling, or go the other way and do 9.6 AC coupled and add another 3 or 4 DC coupled as well. And we have a reference chart in the manual, as well as a tool on our website that I'll show you in a little bit, that'll calculate how much of each one you can have based off of your settings. And then actually did almost forget to mention that one of our coolest features is we have a 4 millisecond transfer time. So unlike a lot of the other guys out there, if the grid goes out, you're not even going to notice for your backup loads panel. The grid can go out, your computer's going to keep working, you won't even notice, your lights won't even flicker. So that's a really cool feature as well. So that's why a lot of banks and server rooms use us as well.
And so you're saying when you're using a Sol-Ark in an AC coupled situation, you can actually go and see what the AC coupled system size is, and then based on what that AC coupled system size is, expand the solar array using the DC MPPT.
Yes, that's correct. And like I said, we do have a tool on the website as well where you can plug in what you already have on your house if you're trying to add to a retrofit system, or if you're starting from scratch, you can just plug in what you'd like to do, all the way from the type of panels that you're using for the DC side through to the AC coupled sizing, and it'll tell you if it'll work or not.
All right.
Okay, so the Fortress actually touched on this a little bit as well, but just to get into a little bit of the specifics here, if you do go for an eFlex or an eVault, the communication cable that you're going to use between the Sol-Ark, which has this handy dandy little labeled port called battery, and that we use for battery communications, you will use different cables for that. So you'll need to make sure that for the eFlex, you're only going to use pins 6, 7, and 8. And then for the eVault, you're actually going to use just pins 7 and 8 on the Sol-Ark side and pins 3 and 5 on the Fortress side. So just some quick note there, that's a little bit different. This will be available for reference as well as being in our manual. And then of course, you can see some of our settings here. Settings in general, just a quick note on that, the Sol-Ark has a touchscreen, so it's really easy to change your settings, as well as the monitoring platform is two-way communication. So if you or your installer need to change some settings, or even if us over here at Sol-Ark, if we're on the phone with you trying to help you out, we can change your settings remotely, so long as you're set up with monitoring. With that being said though, for your battery settings, specifically for battery communications, you would put the system in the mode called BMS Lithium battery. And then you see that little number there. The number 04 corresponds to the communication style that we use with Fortress. And there's a table of those on our manual as well. Other than that, you can change these settings here, but as Fortress John was saying before, whenever we're doing closed loop communication with the battery, what's so cool about that is that the battery tells us how it wants to be charged. So the rest of these settings kind of fill themselves out for the most part whenever you're doing communications. All right, so this slide has quite a bit on it. I'm going to go through it here piece by piece. The Sol-Ark 12K is stackable, so you can either do 208 volts or 208 volts for 2, 3, 6, or 9 systems. That's for 3-phase installs. You can also hook up a system, one single system to a supply that is 208, but it wouldn't do 208 true 3-phase backup. Each system can do 2 phases only at a time. And then with 240 volt installs, which are the most common, you can have anywhere between 1 and 8 systems and anything in between as far as expandability. And then another cool part about that is that whichever unit you define as the master unit will propagate its settings to all the other units. So you don't have to sit there and change the settings, 9 times or 8 or 9 times or whatever it is. We do include CT sensors. Those are going to be the small ones here in this group of 3. Those will fit a 2-watt connection or a 2-watt wire. Those come with every system at no additional charge. If you have a bigger service, for example, aluminum feeds for 200 amps, you tend to be at least 4-watt, and you'll want to get our medium-sized CTs that have the 1-inch internal diameter. Those are pretty frequent. And then every once in a while, you've got a huge install and you need those big 600 amp CTs that have a 2-inch internal diameter. So those are pretty handy. We use those for a couple different modes. One, you can just get some nice data on the usage of the power usage of the building. But most commonly, we use it for what's called limited to home mode, or in other words, meter zero mode, so that if you don't have a net metering agreement yet, you can still produce power and just make sure that your meter tries to get as close to a standstill as possible. And as close as possible is actually programmable. So we have a net zero power target that is programmable in the settings, which is pretty handy. If you want to give yourself a little bit more of a buffer or less of a buffer, you absolutely can. And next up, we've got some time of use improvements. So you can AC couple using the CTs, which are this current transformers, which are these sensors here, and you can charge and sell at different times. But basically, if you have a rate structure where you're getting billed a different amount at different times, and you want to discharge your battery when it's more expensive to buy power from the grid, or any other situation, maybe you have peak shaving, or you have peak demand pricing or anything like that, you can program the system to discharge at a certain rate at a certain time on a particular day of the week. You can get that specific with it if you like in the settings. And again, we do have a separate document for exactly how to do that. But you can see in the bottom right-hand corner, an example of what the main settings screen for that looks like. So you've got some checkboxes here. If you want to allow grid cell, you just check grid cell. If you want to limit it to the home, you would just select limited home, so on and so forth. And then you can also do multiple modes at once in order to achieve more complicated use cases, such as grid and gen peak shaving. Gen peak shaving, by the way, is actually really cool. If you have an undersized generator, we can actually use these CT sensors to measure how much power that the generator is outputting. And if maybe you have like a 8 kW generator and you don't want to pull more than 6 kW to the home, you can actually have the Sol-Ark sync up to the generator while it's running. And if your loads in the house exceed 6 kW, the inverter will actually stop charging the battery and start discharging the battery to help out momentarily for whatever that load was that went above your threshold value, which is really handy. We've got programmable % battery shutoff for generators, so you can, if you don't want to charge your battery all the way back up to full, you can change that set point whenever the generator is called for. And of course, you also have the other way around, where if your battery drains to a particular point, we have 2-wire start, and we can fire up your generator to charge the battery if you hit a particular percentage. We have field replaceable parts. You can do, the field replaceable relays are really handy. Those are on the grid side. And then, of course, we have the 9.6 AC coupling. Quick note on that: if we can AC couple on the load side, meaning the load breaker, or the gen side, meaning the generator breaker. The benefit to doing the generator input is kind of threefold. So one, you're going to actually have a dedicated port for it, and it's not going to be in the main in your backup panel, but you're going to be able to measure exactly how much power your AC coupled panels are contributing, which is a nice feature. And then two, very recently we introduced a software feature where, because you can't have, let me just back up a second here. So in a world where you have AC coupled panels and a generator at the same time, you can't run them both at the same time, because we do something called frequency curtailment to control your AC coupled panels. So they can't be on at the same time, because the generator would define the frequency and we wouldn't be able to tell them to stop making as much power, et cetera, et cetera. You might be able to see how that could be a problem. But recently, in our latest software update, we introduced a feature where if you do the AC coupling on the generator input, we actually have a relay on the other side of that breaker, and we can disconnect your AC coupled PV in order to call for the generator, fire up your generator, charge the batteries, turn your generator off, turn the AC coupled panels back on. And that way it's all automated and you don't have to worry about the two power sources conflicting with each other on any given day. It's a really cool feature. So moving right along here, we do have, some of you may be familiar with dark start. And that's a situation where you could, if you had AC coupled panels only and your battery got drained below your shutdown voltage, you wouldn't be able to turn the inverter on in order to wake up the AC coupled panels, because they only wake up if they see the grid or if it's the inverter pretending to be the grid. So that used to lead to something called a dark start problem. Well, we fixed that with software as well, where we leave a little bit of a buffer in the battery when we shut down, if you do hit the lowest range of your battery. And then in the morning, and we do this in an intelligent way, we don't just do it every 2 hours, we do wait till the sun will probably be up, and we'll fire up the inverter, look for the AC coupled panels, and if we find them, great, we power back up, charge batteries, and we're good to go automatically. You don't have to think about it. And then if we don't find the AC coupled panels, maybe it's still super cloudy or something like that, we'll turn back off again and try again in an hour or two. All automatically, so you don't have to worry about it. Next up, we have some Ethernet and Wi-Fi support. So the dongles that we use for our monitoring actually support both Wi-Fi and Ethernet, which is really handy. I do recommend Ethernet, of course, if you have it available. It tends to be the most stable option, but Wi-Fi works too. And next up, we have, if you have a situation where you're doing a lot of installs for folks that are really off the grid and they don't have internet and they're way out there, we do actually have a local update dongle available for purchase. It's $100, but you can preload the software onto the dongle, take it with you to the site, plug it into the inverter, and let it run. It'll just automatically update the inverter. The inverter will reboot. You'll wait till the lights change and you can pull out the dongle, and that's it. Your update's done. You didn't need the internet. Otherwise, with a regular dongle, the way to get an update is you just give us a call, let us know that you're ready for an update, and we would do that for you via the internet. So, all right, and I see that there's a bunch of questions here on the side. I think we may want to get to those at the end.
I think you'll want to read through them and then we'll get to them at the end, yeah.
Okay, sounds good. So I think I'll move on to design tools. So these are two of the three design tools that we have on the website. The first tool being the one that I mentioned about the AC coupling and DC coupling tool that's on our website. That's under the support section of the installer page. But our first one on the left here is the design your system. This is a really helpful visual representation of the hardware that you're going to need based off of your situation. So you can say, do I have batteries? In this case, probably yes. Am I planning on selling back to the grid? Yes or no? PV coupling, am I going to do it DC, AC, DC and AC, so on and so forth. You can pick, how big of a system you're planning on doing and which components you plan on having, and it'll give you a basic one-line diagram of what you're going to need, which is a real quick and easy way to kind of get that done. It helps a lot of folks understand what's going on there. So that's cool. And then on the other side, we have, I think, an even cooler tool. And this, you can plug in all the appliances that you have, how many of you plan on doing, how long they plan on running for, and the tool will spit out, how big of a battery you're going to need. It'll estimate, of course, but how big of a battery you need, how big of an inverter you need. You might see something called smart loads on there. I can't really talk about that today, but if you'd like to learn more about that, I do highly recommend that you join our newsletter list on our website. There'll be some news about that soon. And then, of course, it gives you a cost breakdown as well. Now, everything is estimated, but this is a great way to get a start in your design process. So if you have, 3 refrigerators, an AC unit, et cetera, you just plug that into this tool, and it says, okay, you need this many kilowatts of inverter capability and this big of a battery. And of course, you can always, in the case of Fortress, you can just divide the kilowatt hour number by whichever model you plan on going with, and that'll give you round to the nearest battery, and that would be how many that you needed. So it's a really cool tool. It's available on our website. I recommend everybody check it out if they have a chance. And then here's a quick view. We did get a brand new app for our monitoring service. This is called PowerView Pro. And it's kind of a new look that can do pretty much all the same stuff, but the biggest feature difference if you've used our apps before versus before to now is that you can actually group multiple inverters onto one plant and view them all at once. Whereas in the old app, you had to go through one by one with different plants. Other than that, though, it still has all the great features for debugging. You can go through and see all your graphs, your data, your production, all that good stuff. One of the cool updates that we did recently also on this front is that here very soon, you see right here on the power flow on the left side of the screen here, that used to be updated every 2 minutes or so. That's going to start being updated every 30 seconds. So it's going to be really close to real time.
That's great.
Yeah, and then here's some screenshots of the desktop application that is also PowerView. So this is our fleet management. You can see here in the upper right, you can have as many inverters as you can install underneath your account, and you'll be able to get to all of them easily from here. So you'll be able to log into any particular plant. You can see the graphs, as you can see here in the middle. You'll get like a power flow that's gonna, again, be every 30 seconds, which is really cool. And then you'll get, you can do custom plots of whatever data that you want to see. You can do your grid voltages, frequencies, PV voltages, loads, battery voltage, percentage, all that good stuff. You can plot it. You can plot like 6 different things at once and try and look for correlation. My team here at Sol-Ark, we use this very heavily to help everybody out with, debugging, getting to the root cause of things and figuring out what's going on, as well as giving suggestions for, maybe they need more panels, maybe they need another battery, something like that. But it's very helpful to be able to go through the data like this. And then, of course, you can see on the left, you can change almost every single setting in the inverter remotely. So you can, as an installer, you can have access to this, or as the customer, you can have access to this. And then we also have different, permissions levels as well. So if for some reason, in your net metering contract, the end users not allowed to change settings, you can give them a view-only version of the profile as well. So all that's available there. Okay, so here is a quick breakdown of some of the improvements that we've done lately. So any of you that have been installing Sol-Arks for a while, or maybe have already done a few installs, you may have noticed some of these things. The DC limiting power for the AC plus DC used to be limited to 9,000 watts. That has recently been up to 11,000 watts, which is pretty handy. Grid fluctuations, we had an issue, admittedly, in the software where you get some F18s sometimes whenever the grid would fluctuate outside of our range. We have majorly improved that, so that shouldn't happen anymore. And then we also had an issue where you'd get an F18 sometimes when you had multiple inverters with a very large generator. That issue has also been resolved, which is pretty cool. And lastly, PCS, that's coming very soon, probably 2 to 3 weeks. There's lots of testing and stuff that had to go along with that, and I'm sure all of you are familiar with the bureaucracy, but that's coming very soon, which I think will help out a lot of people's grid applications. And then, of course, in June, we have a lot of cool stuff coming out as well. We're going to have the ability to see the Gen Relay contactor on the screen. So as some of you may know, a lot of the generator features right now are kind of in the back end. They're not available on the GUI, but they do work, but they're not toggleable in the GUI. So that's coming very soon. Be able to turn off the generator manually for testing, which is really handy. You do get alerts, actually. So some of these are already done. So if the grid goes out and your customer has the app, since the Sol-Ark switches so fast, you wouldn't know that the grid was out. So it's really handy to get a little pop-up on your phone to tell you that, hey, the grid's out. Maybe now's not a great time to do a load of laundry or something, but whatever the case may be, you get that notification, which will be really cool. Then we have an auto generator start failed alert coming soon. You'll also be able to see the generator power in the PowerView chart, and the PowerView or the power flow on PowerView will actually be able to show voltage and SOC at the same time, which will be neat. And we do have some fleet management stuff as well. So grid up, grid down, kind of quick views.
Dylan, can you go over one more time this this particular improvement going from the 9 kilowatt to 11 kilowatt on the DC limited side?
Yeah, so what would happen is if you had, let's say you did 3 kW AC coupled and you had like 13 kW DC at the same time for like the maximum configuration on the Sol-Ark. Before, what would happen is the Sol-Ark would have, in a previous screen, there was a grid cell max, right? And that grid cell max, the most you could set that to would be 9,000 watts. And because of that, the system used to curtail your DC production to make sure that the amount of power going through your grid breaker to the grid did not exceed 9,000 watts. And we fixed that so that we can throw all the AC coupled power out there in addition to how much power it can make on the DC side at the same time up to 11,000 watts instead. So you'll get a lot more cell back on the grid side going forward.
And that's for AC coupled configurations, or both. That's when you have both DC using the MPPT and an AC coupled solar array.
Right. Yeah. That particular improvement only applies to AC plus DC coupling at the same time.
Great. Thank you.
Okay. And then here's just a couple of quick updates for our virtual power plants. We're expecting OpenADR certification with existing hardware to go through on June 7th. June 21 and 28, we're expecting for integrated aggregations. So through Energy Hub, you guys are going to be available. I think it's National Grid that's doing that in June-July timeframe. That'll be really cool. And then, it's going to pay quite a bit towards your battery. So I think that area of the country is going to see a lot of extra battery sales and inverter sales as a result. So just a quick update there. And here we have a smaller version of what we like to call our Christmas tree chart. It kind of does a quick comparison of us versus other popular inverters out there. So I'm not going to go through this exactly line by line, but I do want to point out a couple quick things. So you can see that our peak current is one of the biggest differentiating factors. And we have a whopping 63 amps of peak current, which helps out a lot. You could do a 3-ton AC unit on just one Sol-Ark. Pretty cool, as opposed to a lot of the other competitors that have significantly less. We do have some form of built-in load management with that smart load breaker that comes with the unit, of course. A lot of the other units don't have that. And then, our continuous power from the battery is also really high per inverter. There's not very many, the other ones can't get nearly that high either. And then, of course, kind of one of the funny ones, given that Generac makes an inverter, is that you can do generator charging with us. So we can fire up your generator automatically with our 2-wire start, charge up your battery off the generator, and then tell it to turn off when it's done. And we're the only one on the chart here that can do that as well, so that's pretty cool. And the last thing I want to point out here is that the efficiencies. So if you see our PV to battery to AC efficiency, we're at 93%. And a lot of the other folks are a lot less efficient. And the main reason for that is, we have to do less conversions. We're transformerless design, so we don't have to convert as many times as a lot of these other AC coupled applications. So, most of these other guys that are AC coupled, they're going DC, AC, AC, back to DC, DC to AC again. Whereas we just go DC, 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 AC. So we cut out a whole step there, save quite a bit in efficiency. And that means you need less panels and, you need less battery, but you can always have more capacity in the battery that you have as a result of that. All right, so again, we do have 7 days a week support for our customers, our installers. We do the remote programming. We can help you out with that. We are also happy to take a look at your designs. We also won't do your whole design for your install for you, but we're happy to look at your one-lines, help you through that process, give you feedback as you go. Our install simplicity is great. It's an all-in-one system, so you're monitoring your MPPTs, your chargers, your AC side, the inverter. It's all in one box, and it's also a smart box too that you can program to do all kinds of things. So it makes the install process very easy. And there's a lot of really cool programs that I mentioned before. Utilities are paying customers to borrow for ESS support to the grid, which is really cool, and I think that's going to improve the demand for these kinds of systems going forward. And of course, we have the highest on-grid and off-grid efficiency out there as well. So things to think about.
Okay.
Yeah.
So now we're going to talk a little bit more about the installation day. We've seen a number of Fortress and Sol-Ark installations now in the field in a variety of configurations, and we just want to throw out a couple of design configuration suggestions to make sure that you pass inspection with flying colors. One starting point when you're on site and it's time to program the inverter, we would recommend you go to our website under the resources page, check out our inverter guides, of which Sol-Ark you're going to find right up at the top of the list. When you go to our inverter guide, you will get that invitation to our Discord chat. So if you missed the invitation earlier in the program, now you know where to find it. Go to the Fortress Power website and go look at the Sol-Ark integration guide, and you will find it there along with some other relevant contact information. The inverter guide will help you, walk through the setup of the Sol-Ark based on the latest and greatest discussions between ourselves and Sol-Ark, as well as feedback we get from field installers. And so the step one is to go and program the inverter based on voltage-based controls. Now, if you think that the battery management system will remote program the inverter, yes, there is some of that, but programming the voltage-based controls, particularly with the Sol-Ark inverter, is quick and easy. Just press the battery setup menu and then plug in the values in the inverter integration guide using voltage-based controls, not enabling the battery, not enabling the percent charge. Just, we're going to come back to that. That'll get you up and running. So the advantage of using the voltage-based controls as the starting point is then you can go in and program all the functions as a function of voltage rather than as a function of percentage. So you get that voltage-based fallback programming out of the way in case there's ever a drop in communication between the battery and the inverter. Then you can go back and program the percentage-based controls. What I really like about the Sol-Ark inverter is that the programming of it is simple enough to do in the field, and also simple enough to be accessible to the end user or the homeowner. There are other battery inverters that have very complicated programming procedures, which really overwhelm someone who is not familiar with solar or batteries, such as most end users. And so the simplicity of the Sol-Ark interface means that you can often take a phone call with a customer and have them make sure that the settings are correct, rather than have the cost of a truck roll of the installer to get out to site just to verify the settings. So step one is to program the voltage-based controls. One key is that we disable equalization, so make sure that your equalization is disabled. Not all of these programs settings are things that are set in stone, such as the low battery alarm or the shutdown voltage or the restart voltage. These are more of suggestions rather than ironclad voltage parameters. Advanced installers may be able to play around with their alarm level or their shutdown voltage to get a broader range out of the battery or to turn the alert on in a meaningful way. That voltage open source kind of limitations for voltage-based controls go away. You'll be operating the battery off percent stated charge, but this will get you up and running while you make the battery communication cable. So the next step is to make the communication between the eVault and the Sol-Ark. The eFlex and the eVault have different data coming out of their Ethernet ports, and so because of my haste, I got these out of order here. With the eFlex, all you need to do is take the communication cable, run it between the Fortress and the eVault, and unfortunately, our pinout connection is not exactly the same as the Sol-Ark. And so on these other Ethernet pins, we use other kinds of communication that if they were to land on the communication port for the Sol-Ark, it would be jarble. And the Sol-Ark inverter would not know how to interpret the data coming through it, and that would result in a communication error. So the simple solution is to take the Ethernet cable, cut into the cable, and then snip out wires 1 through 5, only keeping wires 6, 7, and 8. Again, that is on the eFlex battery. So there is a simple solution to just use scissors to cut into the cable jacket, cutting out cables 1 through 5, or you can land just cable 6, 7, and 8 on an Ethernet keystone and then come out the other side of the keystone with an unmodified cable if the cable modification doesn't suit your fancy. But again, it's something you can do in the field very easily with the eFlex battery. With the eVault battery, so again, these are switched up on the title, but they're correct in the integration guide. So with the eVault battery, what we use 6, 7, and 8 for instead come out on pins 3, 5, and 6. And so the pin 3 is going to cross over to pin 7, pin 5 is going to cross over to pin 8. So you say, well, how do I do that? You use an Ethernet keystone where you would normally land, wire 3. Instead, you go land it on the wire 7 slot where you would normally land wire 5. Instead, you go and land it on the wire 8 slot, and then wire 6 goes to the wire 6 slot. We on future eFlex and eVault orders, we are going to start including a keystone in the package, but this is a dollar item that you can get at any big box hardware store for the time being. So, for the time being, for your eVault installations, you will need to have a keystone to make the crossover cable process much more convenient. We have had installers try to field make their own Ethernet connectors with the cables crossed over inside the connector. Because you have to disconnect certain wires and cross over others, doing that with a crimped RJ45 connector is a little bit too difficult. If you only try and crimp 3 wires in an 8-wire Ethernet housing, those wires can jump out of line while you're making the crimp. And so we recommend using a keystone when making the communication with the eVault. The actual port that you land the communication on is going to vary by the model number of the Sol-Ark. So if you're buying, your projects now, you're going to be landing on the battery CAN bus port. If you have open loop on existing projects and you are using the indoor 12 kW unit or 8 kW unit, you may land on a slightly different RS485 port. After you make that communication crossover and land on the appropriate port, then you want to give your closed loop settings a visual inspection to make sure all the data programmed over. So for example, the voltage will reprogram from 54.4 volt charging voltage. Now it'll charge at 56 volts. So this doesn't really translate into additional battery capacity per se. It's more of a faster and more aggressive charge, so that we can charge more aggressively because we have that communication established between the two inverters. The effective battery capacity by having the battery go all the way up to 56 volts instead of 54.4. It's not a linear relationship. It's just a smidgen more power by doing so. When you have closed loop established, that's when you go back and you take it off battery voltage mode and go into battery percent charge mode with a BMS04 activated, and you can do the activate battery feature as well. So BMS04, that is the communication that's needed for the Fortress batteries, both for the eFlex and the eVault. The communication is the same. The only difference is the wires that it comes out on the Ethernet jack between the two product models. We only support closed loop communication with the eFlex and the eVault. We do have another battery in our product line, the LFP series. The LFP series does not support closed loop communication. So these are settings that are just for closed loop communication. And what you'll see is the full range of amperage for the batteries up to the maximum range to fit the eVault and the eFlex to the Sol-Ark. So for example, that will allow you to do 2 eFlexes onto 1 Sol-Ark with the expanded range and still use the full range of the Sol-Ark for that application because of closed loop. So we'll get into the implication of that in a minute. Lastly, because you've programmed in percentage-based controls, you can now program based off percentages instead of voltage levels, and that is much more consumer friendly at the very least. And when you look at the voltage levels, you look at that voltage discharge curve. It's very easy to know when the battery's empty based off voltage. It's very easy to know when the battery's full based off voltage. It's that middle range that becomes the blind spot in terms of voltage-based controls. So by enabling percentage-based controls, you can more readily step down the inverter based on sellback parameters so that you don't, if you don't need to aggressively dump the entire battery in a matter of 2 hours, but if your time of use rate is a period of, say 4 or 5 hours, you can more casually discharge the battery and get a longer life out of it accordingly based on stepping it down on the various percentage levels. Once you're done with the programming, go into the Sol-Ark menu and select Lithium BAT info. You will see some data coming between the battery and the inverter. So when you see a line of data being communicated rather than just an empty matrix of zeros, you will know that your closed loop communication has been successful. You can always look at the battery screen itself on the eVault. It's a screen that'll have actual numbers on the eFlex. If you don't have our CAN bus communication tool, you'll just look at the state of charge indicator lights on the eFlex. You want to verify that the eFlexes are all charging. So there's a blinking light on the status indicator indicates that it's charging. So before you leave site, you want to make sure that all batteries on site are charging and or discharging to make sure that the battery has been properly commissioned. So on the eVault, you can just look at the screen of the eVault. On the eFlex, you'll actually see one of the state of charge lights blinking to indicate that the battery is charging up. If you see all four, all the eFlex batteries on site accepting a charge, you have successfully commissioned the system. The final step will be going into the grid parameter settings to sell the appropriate level of when you want to sell back to the grid and how much. I recommend using percentage-based controls for that. And Sol-Ark has guides available on their website. They mentioned it earlier, the different modes of operation to help guide you on what to put in on the grid parameter settings. I want to talk about layout real quick. I know we're at the end of our hour, so we'll probably have to do email follow-up for remaining questions. But one of the common design configurations that we see is putting the eVault directly in front of the Sol-Ark. National Electric Code will require for the accessibility of the Sol-Ark this depth to be no greater than 6 inches between the front of the eVault and the front of the Sol-Ark. And so the simple solution is just to place the eVault off to the left of the Sol-Ark. The DC input on the Sol-Ark is here. The DC wiring from the eVault can go out either end. And so by putting it to the eVault to the left of the Sol-Ark, that just makes a code compliant and convenient cable run between the two equipment. You could also, if you're going for fancy, you could build a false wall and bring the Sol-Ark unit out from the wall and kind of tuck the eVault into the wall to make up that dimensional difference. And that could play out, on a slightly larger project. No big deal. You put the eVaults off to the left, the Sol-Arks off to the right, and have a trough or a gutter to combine the two. Most installers recommend using an 8-inch trough or gutter, which will bring the gutter all the way out so that you can land the conduit just straight down into the trough and then run all your wires through. On a larger commercial project, again, you could have it look nice and sleek by building that false wall out, putting your combiner box in the middle, and then doing any kind of cable management inside the gutter coming into your single point. I'm showing, the batteries that are closer having shorter conductor lengths. We want all of our batteries to have the same conductor length. So in reality, you're using this trough to kind of manage your battery cable slack. Or going into a bus bar and wiring your bus bar into the trough, or dividing up with power distribution blocks inside that gutter your home runs back to the final combining point. So long as everything's nice and symmetrical and the same length, that will work too. Larger commercial size battery projects. This is kind of the future, when you get into regions that have high commercial demand rate structures, that is often the most cost-effective use of the batteries for commercial demand management. One thing to keep in mind is when you're designing systems for 3-phase Sol-Ark Fortress systems, you're going to want to group your Sol-Arks into groups of 3. There is a specialty case where you could just have 2 Sol-Arks on 3-phase, but I would defer to Sol-Ark to get a little bit more guidance on the backup capabilities of that type of system. For regular demand management, keeping your battery orders in groups of 3 work, and then you start to say, well, how am I going to manage all this together? It's really not that big of a deal. You could have all your batteries coming into a central combiner point location, and then have one wire run, and then put a trough on the wall and come into that point as well. And so, this is, of course, these are project budget estimates, which are going to vary from project to project. But if you look at a project that's like 9 Sol-Arks and 9 Fortress E-Vaults, and that would give you about 81 kW of DC coupled demand management capability on about 166 kilowatt hours of storage. So you could demand manage 80 kW off of the commercial facility peak load. Now this might be a very large commercial facility that has a 500 kW load, but its peak load has a 80 kilowatt hysteresis up at the top where the peak load is jumping up and down. You're using demand management to shave off the very top of the peak load. What this would translate into is nearly a $300,000 project in only about 110 square foot of real estate. And so that's a lot of profit to be made for an installer who can kind of lead the industry in commercial demand management. A solar project up on the rooftop of this budget takes a sizable amount of labor and installation hours and project planning. You can get the same dollar value in a little bitty space inside the right control room, and start making even higher margins and even more cost-effective projects than doing that on their own. There's a lot of commercial rate structures with high demand charges that are not good for solar-only rate structures. The commercial installers out there probably know what I'm talking about. It might be that a smaller solar array with a larger battery and a large amount of battery inverters can result in the most cost-effective kind of project stack on the market. There are also ways to clean up your eFlex kind of small residential job sites. A popular one would just to be put a trough on the wall, and then you can mount the eFlexes on the wall right side up and upside down, go into the trough, put your combiner block inside that trough somewhere and go with one set of wires into the Sol-Ark inverter. I had a site where it was like this, except it was in a floodplain, and we were concerned about the garage flooding. No big deal. You can just move the eFlexes further up off the wall in that case. So our wall mount kits allow you to be flexible. Sometimes this is a better method than just floor mounting the batteries. There's different ways to do it to really get the balance of system material down to a minimum. So like, what's the minimum spend, the smallest project you could sell to a customer? You could give them one Sol-Ark with 2 eFlexes, put a trough down the side, run your eFlexes into a combiner point, and then run that into the Sol-Ark. So you may have questions about how to do battery combining. That's a perfect time to go onto our website, join our Discord group, and then ask your battery combining questions in there. Last but not least, I want to point out we also have some design tools. I really like, Sol-Ark's ability to build a simple one-line diagram on their website and to do some load calculating tools for our Fortress Power installer dealers. So people who have gone to our website, installers who have filled out our installer dealer application. So it's both for distributors and for installers. That will give you access to the dealer resources portion of our website, where we have this a little bit advanced spreadsheet for doing things that other even commercial software online doesn't do this level of analysis, where you can take your 12-month electric bill history, put in your solar array size, select how many eVaults or how many eFlexes they'll do, and it'll break out your system production based on PV watts data and how much electricity is going to flow out to the grid versus, say, on site. And so let's say you're in a situation where the utility doesn't pay you anything for electricity sold back to the grid. You can adjust your solar array size and your battery size until your solar outflow is reduced to a negligible amount. amount so that the losses associated with overproduction are negated. So you can see, you can talk to the customer to say, well, if you just built this 6 kilowatt array, without batteries, then 40% of that production is going to be sold back to the grid at a loss, whereas you go and you add the 2 batteries, you're not hardly selling back anything and getting those project economics back up to where they should be, while also having backup power added to site. So you can start to break out how much of your solar production is instantly consumed on site rather than being sold back to the grid in that moment. How much of your solar production is then going to be either sold back to the grid or stored into the battery. We'll take a look at how many hours you're going to be running either your grid charge or your generator, and that will tell you how reliant you are on that grid charge or generator. Maybe the right design for the customer who wants to go off grid is not to be completely off grid, but to accept reliance on the grid or the generator for a couple of hours a day, a few days a year. That will help you break that out. So our design tool will tell you how many days a year you are using your grid charge or generator charge and how many hours per day you're using that, to show you how much of the year you're running off the grid or the generator, how much of the year you're running off your battery or your solar array. And by designing your system around the customer's expectations of grid reliance, you can say, hey, look, in this system, you're not going completely off grid, but you're only using the grid for a few hours a day. During a real extended grid outage, you can curtail your energy use, and as long as you reduce your energy use by 4 out of 24 hours, as long as you reduce your energy use by about 15%, you'll be able to get through those days completely fine. Or you can keep adding more solar and adding more batteries until you don't need to run the grid or generator for more than a dozen days out of the year, and that would be more like an off-grid design. So the more solar you add, the more batteries you add, the closer you get to off-grid design. The cost-effective system doesn't necessarily take a home all the way off-grid. This will provide you some analytics to more intelligently discuss what the usability of the system is going to be like for the customer. So that is the end of our program. We're about 10 or 11 minutes over. I'm more than happy to continue this discussion. But for the time being, I'm going to pass it back to Dylan. He's had a chance to review some of the frequently asked questions. And Dylan, if you have the time to stick around, feel free to go open range on these questions and rattle off some answers if you know them.
Sure. Yeah, I'm happy to do that. We can go through quite a few here. All right, so let's see. I'm going to try and scroll up to the top for some of the more first questions here. All right, using a generator, input 63 amps path through. We can upstream ETS with grid. All right, so I'm going to go through some of the faster ones here. So would the screen fade over time due to direct sunlight? Yes. So if you have an outdoor unit, the only thing about it that's not like perfectly good to be outside all the time is that the screen doesn't like to be in direct UV exposure at all times. So some kind of, you can either put a cover on the screen, or if it's just got a little bit of shade or something like that that keeps the screen from getting hit by direct sunlight all the time, that would be great. Otherwise, yes, the screen would fade over time. Can the inverter charge batteries from AC coupled solar when off grid? Yes, it can. We use frequency curtailment to control the AC coupled production when you're off grid. So we definitely can do that. All right, so I experienced the 4 millisecond transfer. My problem is actually knowing that I'm on battery so I can actively manage it. So yes, that's why we added the pop-up on the app. So if you have the app and you have your system registered to your phone app, if the grid goes out, you'll get a pop-up that'll tell you, hey, the grid's out, and that way you can manage your loads appropriately. Can the Sol-Ark support optimizers? Yes, there are some optimizers that we do support, primarily the ones produced by Tigo. An important note on that, though, there is a built-in 12-volt RSD power supply in the Sol-Ark, but it is only rated for 100 milliamps, which is not enough to power the optimizers. I believe they call it their Cloud Connect Advanced. That has its own power supply. You do need to use that. You can always put its power supply on the load output of the Sol-Ark so that it's still, off grid and all that good stuff. But just don't power it with the 12-volt supply directly. But yes, that's a long way of saying, yeah, you can use optimizers if you like them. Let's see. What is the maximum peak starting current the Sol-Ark can handle, and for how many milliseconds, seconds, minutes? Okay. So we don't have any peak ratings that are in the range of minutes, but we can do, I think it's for 100, and I'm trying to go off the top of my head here, for it's 100 milliseconds or so, we can do 25 kW, and for 5 seconds, we can do 20 kW peak, assuming you have, all the PV and battery available to do so. If you're doing battery only off grid at night, you're looking at more like 16 kW for 5 seconds for your peak. Was a paper manual supposed to be, let me expand the page to read the rest of this question, but I assume you're asking if it's supposed to be in the box. There is usually a paper manual included in the box with your Sol-Ark. If you did not receive one, it's available digitally on our website, or you can give our support team a call if you'd like a physical copy, if you've purchased the system, of course. Do the systems come in 50 hertz? Yes, we can do 50 hertz. Here's a manual was not in the box. So if you didn't receive a manual in the box, I'm sorry to hear that. We do normally include a manual in the box, but like I said before, it's available on our website. The latest version is in a digital fashion, and then of course, if you really prefer to have a paper one, give our support team a call. With the zero export power option, do you still need to have an interconnection agreement with the utility? No, so you're not actually going to get your meter to go backwards, and you can adjust the buffer that you give yourself to make sure that you never have any transient net power flow going back against the meter. And so as far as the utility company knows, you're just using less power. Under grid cell setting, why is the 9,000 number the default? That is because the PV production that we can do on the DC side is limited to 9 kW. But again, we did actually change that with a software update now to where if you have a large amount of AC and DC coupling simultaneously, you can actually go up to 11. But that's why it's a default of 9, because that's the max PV to AC continuous number, and also battery to AC number as well. What is the maximum load imbalance the Sol-Ark can handle in split phase and in 3-phase? Also voltage imbalance. So voltage imbalance, you can have pretty much whatever the grid will allow for, and then when you're off grid, we're actually more stable than the grid a lot of times for the voltage side of things. But 10, 20 volts is no big deal if that should occur. As far as the load imbalance, there's a couple different ways of doing that, but the general answer to that is 4,800 watts. So that's like the upper ceiling. If you had 0 watts on like L1 and you had 4,800 watts on the L2, you wouldn't trip till you get to 4,801 watts. Now, if you have 3,000 watts on leg 1 and then you get to 4,800 watts on leg 2, it would still trip. So it's kind of like a ceiling, but your max differential would be 4,800 watts. All right.
Here's a question we get asked a lot. Can the Sol-Ark be used without batteries off grid? So is there a way to run the Sol-Ark with no batteries and no other grid charge, just off solar only? Imagine it were a sunny day with no clouds.
No. Well, we utilize the battery as a buffer to power loads. Solar panels don't really react that quickly to fluctuating power demands. So you do need a battery if you're going to work off grid. You can run a Sol-Ark without batteries if you're on grid and just treat it like a regular grid tie inverter. But if you want backup power, you will need a battery.
Do the Sol-Ark inverters operate with 50 hertz?
Yes, they do. And there's quite a few questions in here, so I'm trying to get to them all. The Ethernet used for closed loop communication can be regular Ethernet cable. I really need to patch this to cables. Okay, I guess that's kind of a question for both of us, but you can use a regular Ethernet cable, but you do need to modify it as was discussed in the presentation for Luis.
Let's see. I'm going to take over emceeing some of these questions. It'll make it, I think, a little bit easier for you. And the PowerView Pro monitoring, is that compatible with the 8 kilowatt kind of previous generation inverters?
Yes, if you have an older system and you'd like to update your dongle, you can. They're available for sale.
Are there any special considerations when doing wind generation with Sol-Ark for programming that might be any kind of pitfalls that an installer might stumble into on their first time doing a wind project?
Sure. So there's definitely some things to keep in mind whenever you're doing a wind install as well. There's several ways to do that. You could DC couple it with its own 48-volt charge controller into the battery. And the main consideration there would just be that make sure that the charging of both power sources at the same time don't exceed the battery's capability. But you could also AC couple your wind turbine into the Sol-Ark as well, in which case you would just treat it like any other AC coupled power source. So the same considerations for microinverters would be applied.
When connecting the Sol-Ark to the internet, is it Wi-Fi only, or can you plug it hardwired into the internet to give it internet access?
You can hardwire it, but it goes into the dongle, not into the user area. So the little dongle on the side of the unit, you can take a little plug out of the bottom, and there's an Ethernet port on the inside for newer models. And then, of course, Wi-Fi is also included.
Do we need to, for customers who are selling the EMP hardening features, do the battery circuits need the EMP hardening cores put around the battery conductor links?
So the thing with EMP hardening, as far as we can tell so far, we haven't been able to find a battery that isn't kind of like an EMP immune battery that's going to be okay with an EMP situation. Now, I'm sure that in theory there's several ways to probably harden something like a Fortress battery, but at this time, as far as we're concerned, the only batteries that we would use for somebody that's serious about EMP hardening would be like a lead acid or some other kind of quote unquote dumb battery that doesn't have a board inside.
Yeah, what I would say is in that true survivalist disaster scenario, you might have to, if the board fries, you might have to open up the battery and latch onto the cells directly, which we don't allow you to do in order to get the 10-year warranty. So it's a little bit of a trade-off between a battery you can beat up and a battery you can actually, sell to a customer under a significant warranty life. Hector asked, how does Sol-Ark and Schneider with eVault compare? What I would say is, as far as cost-effective design, the Sol-Ark, when you look at what it can do, taking 13 kilowatts of solar, with a Schneider, you're going to need 2 or 3 of their $1,000 charge controllers. And then you look at the output size of the Schneider inverter versus the output size of the Sol-Ark. The Sol-Ark inverter is a little bit larger, and that's the difference between being able to put, say, an air conditioning unit on the inverter versus otherwise. So, maybe the Schneider unit can handle, a smaller project in a little bit more of a targeted fashion. But, when you're buying a pallet of solar modules and wanting to do, significant backup as a starting unit, you're not going to get a more cost-effective stack than doing, say, the eVault with Sol-Ark inverter. Okay, any problems with experience with harmonic distortion, given that it's a transformerless inverter?
No, we have very low THD, less than 1%. And actually on that note, we can deal with very high THD generators as a kind of a cool feature that we can do. So Yeah, there you go.
Okay. What about Tigo compatibility? Is it compatible with both the rapid shutdown only boxes and also the optimizer Tigo boxes?
Yes, so you can use RSD only and use that with the RSS transmitter powered by the built-in power supply in the Sol-Ark's user wiring area. And then of course you can do the optimizers, as I mentioned before, where you can't use the built-in 12-volt power supply, but you can power the little AC to DC adapter for the Cloud Connect Advanced box that usually comes with the optimizers to do it that way. But yeah, they both work.
Brian, you asked if you can do one eFlex with the Sol-Ark and still have the warranty. The answer is no. We only warrant the minimum of 2 eFlexes with one Sol-Ark. You really have to work in the industry to quite understand why not always can the software controls throttle every single instance of electrical power going in from the AC side through the DC side. So smallest eFlex we warrant is 2 eFlexes, 1 Sol-Ark. Even if you have an out of warranty battery configuration, what we're saying is we're not going to be on the hook for all the replacement parts should they fail because you have an undersized battery bank. But I still think that, a Fortress battery is a battery that outside of a warranty, if my battery and was outside of a warranty, I'd still want it to be Fortress because you can still get support, people on the phone. The difference might be buying a replacement fuse or a replacement BMS board rather than, being completely out of luck and not having any remedy at all. So yeah, I know with these undersized battery banks, it is disappointing to get a warranty rejection letter for not, designing the systems within spec. I mean, you're looking at a inverter that can charge at 185 amps, and the maximum charge that the eFlex can accept is 100 amps. You say, well, I can program it down to be 100 amps. There's not just continuous output. There's 5-second, there's millisecond electrical transfers, and not always can you program around the speed of electricity. At the same time, if you do have a system that is outside of warranty, you still will still be a company that you can talk to and get support on rather than just being, blowing in the wind. Slide decks, we put these training resources in our Discord group. So if you want a copy of the presentation, go take a look at the Sol-Ark inverter integration guide on our website. Use that link in the guide to join our Discord group, and you'll get a copy of the presentation that way. What's the point of connecting the communication cable between the eVault and the inverter if it doesn't support closed loop communication? It does support closed loop communication. So, we went through a period of time where we were still changing up the control boards on our various products on both sides of the manufacturer end. And so, we originally intended the eVault to have closed loop communication with the Sol-Ark. It is now officially supported up to 2 eVaults per, or up to 2 eVaults in closed loop. If you're not going to do closed loop, let's say you have a 12 eVault installation, then there's no point in connecting the communication cable. Number 2 limit will be expanded with future product generation. But for now, what we see is either it's a large commercial project, we're going to have a tremendously large battery bank at which, the battery empty or the battery voltage high is really what your triggerable effects are. Customers, end users, residential customers, they want to see that percent state of charge, at which case you'd have to use the eFlex if you were wanting battery storage capability larger than 37 kilowatt hours, although stay tuned for product announcements in the future on that. The continuous output of the eVault, just refer to the spec sheet. It's about 8.5, 9 kW. We design our batteries to be 2-hour batteries. So, the rule of thumb is to take the battery capacity and divide by the maximum inverter output. And if that that benchmark is 2 hours or longer, you are in the appropriate range. The altitude cap for the inverter and the battery warranty. That's a good question. We've been looking at it more closely lately at Fortress. We warrant our batteries up to 9,000 feet or 3,000 meters. I don't know if Sol-Ark has any altitude restrictions on their end.
We don't have a specific altitude restriction, but we can go at least 10,000 feet.
Yeah, so that's important because there are certain inverters, such as microinverters, that are not always listed for high altitude. In fact, when we started to get more questions about altitude testing, we had to go and test our products in low pressure environments to make sure that we could warranty it on our own. So without getting into the internal circuitry on which capacitors are not particularly well suited for high altitude, we have tested our batteries and do warrant it for altitudes up to 9,000 feet. What is the recommended breaker size for the Fortress eFlex when using a battery combiner? I actually don't recommend using inline overcurrent protection. You're more than welcome to. The Victron Lynx has a very cost-effective battery combiner system, which coincidentally uses inline fuses. But the battery itself has a fuse for catastrophic events inside the eFlex. The BMS control also regulates over amperage. I would love for someone to email me an area National Electric code where it says 60 volt DC or less requires inline overcurrent protection, because as finally as I have read code, I have not found that requirement. Because of that, keep it simple. There's a variety of battery combining options you can use, ranging from power distribution blocks to your own bus bars. You can look at UL calculations for bus bar thicknesses. So often the easiest way to combine batteries together is to put a power distribution block or a bus bar inside the trough between the two batteries and the Sol-Ark, and that's going to be a lot cheaper than battery combiner blocks of yore. Now, I do think having some sort of, when you have paralleled circuits together, some sort of overcurrent protection is important, but you already have that in the battery management system inside the eFlex internals, so you don't have to pay for it again. The only battery in our product line where we recommend you use inline fuses is the LFP series batteries, which weren't covered in this presentation. We recommend maybe 60 amp or 80 amp slow blow fuses for those because of the type of battery management system they use. But the eFlex and the eVolt are rated for high ampacity. They can tolerate battery to battery backflow, and if it gets to be too much, the battery management system will cut it off. Is it possible to prepare an eVolt for outdoor conditions? The eVolt is an indoor product. Only the eFlex is for outdoor conditions. So if you're going to put the eVolt outdoors, you would have to put it in a cabinet that would provide adequate weather protection. Inside that cabinet, you would also have to regulate the heat. So you need to have ventilation in the cabinet to make sure in the summertime the heat from the system does not overheat the battery. Likewise, in the wintertime, you'd have to have a thermostat in the cabinet to heat the battery to make sure that it doesn't operate below freezing, or more specifically, does not operate below 50 degrees on a regular basis, 50 degrees Fahrenheit, to maintain that full warranty. So we do have a warranted temperature condition, and then we have an absolute temperature condition where if you operate the battery below that, you'll not only void the warranty but damage the battery. We don't want you to do that. In an outdoor installation in a cold environment, the solution is to put the batteries in a cabinet and then heat the cabinet. If you need suggestions on battery cabinets, we can provide them. Just email sales@fortresspower.com for that. If we install the eVolt below the Sol-Ark with large cables to move the eVolt in front, are we meeting the NEC space rules? Yeah, that's a good way to kind of cheat the system, is to, there's a whole there's a whole aspect of design that says, do you need the battery cables to be inside of conduit or not? The answer is no, you don't need the battery cables to be inside of conduit. The conduit requirements come in when the battery area is not a protected area, or if the battery area is subject to vehicular damage. So the conduit requirements for DC to be in metal are for solar output circuits, which are fundamentally different than short battery runs between the battery and the battery inverter that are in the same room of each other. So what you could use is cord grips with battery conductors, and then give yourself enough battery slack to have the battery be wheeled to the side if you need to step up and program that Sol-Ark inverter. Let's see. Recommended rapid shutdown for grid-tied system. I don't know. There's a number of options out there. What's important is that your rapid shutdown system is tested for and officially supports the inverter you select. So I would stick to that. I would go with Tigo for that. Luis, how do you access the dealers? Do you have anything to say on that?
Tigo or AP Smart are the two that we see most often with Sol-Ark.
Okay. Do you ever see Fire Raptor?
Yes, those work as well. Primarily in Canada, I believe, but yeah.
Okay. Yeah, there are some nuances between those products. I think anyway, maybe we need to have a webinar with rapid shutdown discussion included too. How do I access the dealer tools on the Fortress website? It's hidden away in our website menus in our resources. Then you go to the resources tab and go to dealer resources. Probably the easiest way to get access to that sizing tool that I was talking to about. Yes, it is on the dealer resources section of our website. It's also in our Discord chat group. And so if you go to the Sol-Ark integration guide on our website, click the join Discord link hidden away in the Sol-Ark integration guide, then you'll get access to that sizing tool. So are these tools available on Fortress's website? Again, join our Discord group. We actually have you, to use the tool, we have you go to PV Watts and download the data and copy and paste it into our Excel spreadsheet. So what the tool does is it creates a spreadsheet for you that'll be custom to your project, makes it real easy to keep your system data rather than reload it in the tool without messing with a bunch of user accounts. We have a 1-hour training video on the theory behind our tool if you're interested in better understanding it. Again, copies of the presentation or tools, we encourage you to join our Discord group. Not only will you get access to the presentations and recordings, but you can text message with our technical support department as much as you'd like. All your design questions, including the content covered in this program for follow-up discussion, go right ahead. eVault listings for 9540. So our eFlex is listed to 9540. The eVault, we should be getting confirmation on the 9540 listing any day now. This is a process we began testing with Intertech back in March. We have received notice that we have completed the testing, which you do not do unless you successfully complete the testing. And so we are literally just waiting on the official letter to start putting the 9540 label onto it. Can the units be used with SolarEdge optimizers? Only with AC coupling. You'd have to use the SolarEdge inverters and stay within the AC guidelines of the Sol-Ark unit. Let's see, for the eFlex batteries, again, for the breaker size, the way that I would size the breaker to be, let's say you're in a jurisdiction that says we're going to require inline fuses, I would take the 100 amp maximum output rating of the eFlex and then put a 25% over allowance, and so the breaker size would be 125 amps. If I were putting inline fuses and battery combining, I would use the Victron Lynx battery combiner. with their mega fuses. Let's see. We're talking about some load imbalance questions. Load imbalance is tricky. It's more of an impact, I believe, if you have no load at all than if you have some load.
Yeah, I'm looking at that one right now. So, yeah, to clarify, if you had 2,000 watts on one leg and you hit 4,800 watts on the other, then yes, it would trip.
Let's see, do you have a cabinet for the Sol-Ark inverter and the eVault 18.5 for outdoor installation? I don't think you have to put the Sol-Ark inverter in a cabinet. I wouldn't put it in a cabinet just to protect the LCD screen. Instead, I would shade the cabinet or put it, on site, located in a spot where it's not going to get direct exposure to the sun. I don't know. I mean, when you start putting all the equipment in the cabinets, you have to look at things like heat ventilation and how to ventilate it. If it were an outdoor installation, I would use eFlexes instead. We can make cabinet recommendations where you can hang 3 eFlexes on a wall, or have a closer discussion with that. We are actually having a prototype made by a Canadian cabinet manufacturer that will go on the wall outdoors, and you'll be able to hang 3 eFlexes inside it. So we're waiting on the prototype to be shipped to us for final evaluation before we go in production on that. But if you talk to our sales reps, you'll get in on the first batch of orders for that, which will be a good fit for outdoors. I mean, the thing is, it's not just the water that degrades the battery cells, the humidity does too. And so if you're going with an outdoor installation, given that the cabinet needs to be vented, going with a sealed battery such as the eFlex is the better choice. And you can hang it on the wall, which you're not going to be able to do with the eVault. Is there a special breaker configuration needed between solar and the Sol-Ark for being transformerless, or can the positive or negative cables go directly on the inverter? I believe the Sol-Ark can take 4 strings that it parallels 2 strings and 2 strings on the block. That's correct, right?
Yeah, so you'll wire the PV directly into the MPPT inputs on the Sol-Ark. A couple notes on that though, it is an ungrounded system, so if you do decide to use a DC combiner panel, make sure that each MPPT is separate from each other. If you try to use a common negative between Sol-Arks, you can have issues.
So for a big backup system with multiple Sol-Arks, should each Sol-Ark have its own backup panel, or is it possible to unify all the Sol-Arks into a single backup panel to handle big loads? When doing, say, a commercial system with 9 Sol-Arks in parallel with each other, what's the backup strategy? Do you need to have, or should you use an external transfer switch? Can you talk about that at all, Dylan?
Sure. So of course, if you're using Sol-Ark 12Ks, you can combine their outputs into one larger backup panel for larger loads. In terms of how you would do all the sizing for that, you can do about 3 tons of AC or 3 horsepower per inverter. And then, as far as transfer switches and that kind of thing, and whenever you get up to more than one system in parallel, you'll see in all of our recommended diagrams in our manuals that we do recommend putting in a bypass transfer switch. But that's just for convenience. If the inverters need to be serviced or something like that, you would do a manual transfer to bypass the grid through. And maybe that's what you're referring to. But other than that, though, you don't really need another switch, because the Sol-Arks themselves will do the switching between a generator, AC coupled stuff, when the grid goes out. All that switching capabilities built into the Sol-Arks already.
Dylan, not an exact figure, but how much demand do you see on Sol-Ark side for larger paralleled systems such as commercial three-phase for demand management?
I'm definitely going to have to ballpark that. It's hard to know off the top of my head, but there's a large amount of demand, especially recently, for bigger systems. I've seen a huge uptick in the number of people doing, well, 2 systems. Obviously, that's been very popular, but I've seen a big uptick in the 6+ category as well lately. So we've had a lot more people going with commercial size backups for sure.
Okay. So be honest, as you just land on the bus without a breaker. Yeah, so with the eFlex, you do have a push button disconnect switch on each eFlex, and then you have the disconnect on the inverter. And so you can land just directly on the bus without a breaker and still disconnect everything from either end on all the batteries. Not, maybe you'll get inspectors who say, well, I want you to have an external disconnect or an external inline fuse. If it were me, I've been a solar contractor, I've passed the master electrician exam. I would go back to that inspector and say, can you tell me in code where these things are requiring these external fuses? We have tons of supplementary overcurrent protection in the circuits already, but where is the mandate for that inline fuse? The reasoning behind that is that there are definitely batteries out there with battery management systems that you absolutely want inline fuses for, even if code doesn't manage it. Our LFP series being the same way. The LFP series doesn't have the communication between battery to battery. It doesn't have the closed loop, and it's more in depth than that. Not even really focusing on the battery to inverter communication, but the battery to battery communication on what turns things on and off. But also it's where the control board is related to the rest of the battery system. Is it on a dedicated board or is it a shared board? What is the ampacity for that communication board for the battery management system? There's a popular chip called a MOSFET, and the MOSFETs are very popular on many battery management systems, including our LFP series. The problem with the MOSFET-based BMS is if you run them at 100 amps continuous or more in charging, that's right beyond the spec of what MOSFETs can take. And so if you're going with a MOSFET-based BMS, you absolutely have to have, overcurrent protection with parallel batteries. Otherwise, your battery-to-battery backfeeding can burn up the BMS board. But the eVolts and the eFlexes do not use MOSFETs for their battery management system. They use digital processors, like an Intel processor that runs your computer. And so it's on a dedicated board, and the system is designed for high ampacity that you get into when you have parallel batteries where the batteries are balancing each other out. So for that reason, because there are already fuses inside the batteries, because the battery management system is providing additional overcurrent protection on top of that, I would argue to the inspector that's requiring the external fuses to A, justify it in code, and B, remind them that you already have, a ton of supplementary overcurrent protection in line, the breaker on the Sol-Ark unit, the fuses inside the eFlex, the battery management system itself. Less of a concern with the eVolt because it does have that double pole high ampacity DC breaker coming out of each eVolt, which I'd say is pretty inspector friendly. So Fausto, the LFP series does not need closed loop communication. In closed loop communication, it allows you to kind of have a turbo mode on the battery. It does, allow us to warrant smaller battery configurations towards the top of the maximum range of the battery. But the main advantage from the consumer side is that you're operating off percentage-based controls rather than voltage-based controls. So, operating open loop is fine, and if you just want to trigger things based off the battery being full or the battery being near empty, the voltage-based controls can be very accurate. It's just the general public, we want when we buy something, we want to use 100% of it, not 80% of it, even though using 80% of it might be better for us than pushing to the extreme. When we look at our cell phone, we see the battery indicator, we want to see what percent of it's full, not what voltage the battery's at. So a lot of the value in closed loop communication, from, yes, it's nice to be able to push the batteries to their maximum limit, but it's more a consumer value so that they can see the true percent charge of the battery coming from the battery computer, and not leaving it to the inverter algorithm, which, face it, the battery market is changing so fast, the inverter algorithms are not going to be as accurate as the battery manufacturer algorithms. So, for the customers who are living in the digital age, they want an app on their phone where they can pull up and see exactly where the percentage is of the battery. You got to use closed loop communication for that. Does Sol-Ark have any application notes on phase imbalance?
We don't have one that's written down at the moment, but there's one in the works. Absolutely. So we'll have one soon. And if you have any issues with phase imbalance, or like if you're doing like a big 3-phase install and you need some help figuring out which phases are which and where they all go, please do give us a call. We can help you through it for now.
I'd imagine there's also some devices, 120 volt devices, that have large loads like hair dryers, where those, they could put a soft start onto that circuit to, an inline resistor to reduce the surge capacity. While that might, increase the energy use of the application a little bit further, often with off-grid systems, for those types of devices, you can use them, at times when the battery is full, and it's just a matter of not tripping everything. So you might have to, if you're in a phase imbalance issue, you might have to do a little bit more of a, appliance-based solution to reduce the surge load, the 5-second or less surge load of those devices.
Yeah, and it's also heavily dependent on how many systems you have, and if it's 208 versus 240 and all that kind of good stuff. So.
All right, I think we've made it to the end of our questions. If you've asked a question and we've skipped over it somehow, please type it in or just follow up with the relevant technical support group directly. Other than that, I've really appreciated Dylan's time to tell us more about the Sol-Ark systems, and thank you everyone for coming and asking such good questions and being responsive. Don't forget to check out the Fortress Power website for more information, and to join our Discord group too, because it's fun to do so.
All right.
With that, everybody have a good rest of the day.
Thanks, everybody.
So we will put the webinar online in our Discord group. Go to the Fortress website, check out the inverter integration guide, find the invite to our Discord group in the integration guide, and then you will get a copy of the presentation.